this, you kind of asked about this with, are they going to be more complicated equations? And I answered your question, Alan, by saying probably not, but they might ask you to have a more complicated like sketch, right? That sketch was pretty straightforward. Just find the one that's a line. In this one, it's a little tougher. So if you look here, we have a slope field, and they're focusing on 2 points. One that goes through 3, -1, which is here. And we want to sketch another solution that goes through 1, 2. So what I try to do when I teach students to do this is to try to draw something that follows the slopes in your slope field. All right, so I think you probably can see if I start with 1, 2, that if I draw something, I need to draw a parabola. Do you see how if you follow those kind of slopes, you kind of need to draw something that's a parabola? You can see, I know, I'm not saying like this is like easy stuff, but hopefully you can start to see that pattern. So just do your best to follow the slope fields. That's going to allow you to draw a parabola.
How did you get that point?
They gave me that point. It's already there. They told me to draw a solution.
It's like 1, 3.
It says 1, 2, right?
No, like your graph, what's your graph?
Yeah, I mean, they're giving me that point. I agree with you. It does not look like 1, 2, but that's what they're talking.
Wait, could the lines be like anywhere in the field?
The lines, you mean the slope fields? Like the slopes? They could be anywhere, yes. But I'm trying to draw something that matches those slopes.
Yeah, I mean, like the line doesn't represent a dot.
The line doesn't represent. It does represent a point.
No, I mean like not like it's 1, 1, and that's a line.
I see what you're saying. Yes. Okay.
It doesn't.
I'm confused. Essentially, if this is 1, 1, if I plug in 1, 1, I should see a slope of 1. And is that a slope of 1?
So
Yes. So they should match. Yes, he is right. This point 1, 2 looks like it's not correct. Like they graphed 1, 3, which it's an AP classroom from an AP exam. It could have been a mistake. There are mistakes I find in AP classroom. I find them. So could be a mistake. Now, is everyone okay with this one? I think this one isn't easy. I think this is the easier of the two. Because what do you think students are going to do to graph this one? Like a solution. They're going to essentially do a sideways parabola. But here would be the issue. When you draw a solution, it has to be a function. So don't draw this. But if you draw, don't draw this. If you draw this, is that a function? No. So if you draw that, that's what most students will draw. It will be wrong. So what I do is I actually go here because it's got to go through this point. I draw that. But you can keep going until 0. But what happens when you plug in 0 for the y value? What happens when you plug in 0 to that y value up there? It doesn't exist. So do you know what kind of dot should go there if it doesn't exist? An open circle. So that is a function. It passes the vertical line test. But if you keep going, right, if you keep going around the other way, that does not pass the vertical line test. That's not a function. So just be careful when you're doing this. When you draw a solution, a particular solution to these differential equations, they need to be functions. Okay? All right. Let's go to B. Everyone's favorite. We get to do it again. I don't know what that means. What? B for Bustamante? X over Y. All right. Now, so far, I kind of like this one because it's just X and Y. That's a lot. It looks a lot nicer so far than like the trig that we just had. Move the Y over, and you get Y, times dy. And then move the dx over, and you get x dx. You guys good? Okay. You're behind. Okay. Do the antiderivative of both. What's the antiderivative of y? 1/2 y squared. Remember, you add 1, so 1 at the power plus 1 is 2. But we need to do the reciprocal so we don't have a number in front. Equals. Actually, the same thing over here, right? But this one gets plus c. You know that I'm going to solve for y first to find the general solution, and then I'm going to plug in the initial condition. All right? So the first thing I notice is I have 1/2 kind of on both those things. How do I get rid of those 1/2s? You can, yes. I'm going to multiply everything by 2 is the mathematical way to say that, but yes, you can cross them out. So it's y squared equals x squared plus c. Multiplied everything by 2. Notice I didn't write plus 2c. It's just a constant, so you can leave it alone. Just keep it as c. How do I get rid of that square? The square root. Now, technically, what should go in front of this radical? Plus or minus. But take a look. You guys have done this already a couple of times. Take a look at the initial condition. What is the y value there? It's -1. So I'm not going to write plus or minus. I'm going to write the minus. This right here is the general solution. How come I put a square root where? Well, because the square root of y squared is y. Do I need to show the step? I'm sorry, I'm going. My brain knows I'm taking the square root of both sides, and I don't need to write it for the left side because the square root of something squared, those are inverse operations, so it goes away. Plus c. Plus c is in, it's got to be in the radical. Yeah, because it's a part of what's being taken the square root of. Good question. Yeah, that c's got to be in there. Okay, plug in what you know. The x value is 3, and we said the y value was -1. Okay. Now, the first thing I notice is I have a negative sign on both sides, right? Kind of like what Georgie said. We're going to cross those out. You can also think mathematically moving -1 to the other side makes a negative over a negative, which is a positive. What's 3 squared? 9. Now, how do I get rid of that square root on the right side? So now I got to square both sides, which is 1 equals 9 plus c. So what is c equal to? -8. So go back to this step and write down your particular solution. Could you write plus -8? You could, right? I'm not going to. Now, we're not done yet. In the question, it says to find the particular solution, which we did. We have checked that box. But it also says, Bernadette noticed, it says state its domain. What that means is I need you to tell me what x values could I plug in where I would be able to find a point. And the key thing I need you to know here is where is that x? It's under a square root. And what do you know about taking the square roots of numbers? You've got to be cautious of happening, of having a negative number. You cannot take the square root of a negative number. So as long as I get positive numbers under the radical, I can take the square root of it. So essentially what my brain is thinking, as long as this becomes positive, right, greater than 0 is positive, then I'm good. So if I quickly solve for whatever that is, then I know what my domain values are. Remember, 0 is okay. So technically I should put this because you can take the square root of 0. I solved this. Move the 8 over.
Wait, why is 0 okay?
The square root of 0 is 0. Do I need to show the work, Kyle?
Oh, I get it.
Do I need to show the square root of both sides? Okay. Do you need to do this? The other ones.
The domain?
Yeah, this is the domain. Yeah. That's the domain. As long as you plug in an x value that is greater than or equal to plus or minus the square root of 8, when you take the square root of it, hold on, I might have to amend this. Let me check. No, so I can't, I lied to you. It has to be just this. Because if I plug in 0, which would be in between those values, 0 squared is going to be 0, 0 minus 8 is going to be a negative. So it has to be just the positive version.
So do I get the square root
So-
before I
So,
solve it? Or
No, you move the minus 8 over, and then you take the square root. So here is where I took the square root of both sides. So there's two things they're looking for. They're looking for the particular solution and the domain.
oh.
So just be